Hi, everybody out there in Karma Land. My name is Jeff Edwards, and this Friday, January 24th, 2012, I'll be delivering a Karma webcast on the use of spline regression in the study of congruence in organizational research. Now, congruence refers to the fit, match, or similarity between two constructs that are commensurate in some respects, such as the requirements of the job and the abilities of an employee, what a person wants and what they receives on various dimensions from their job, the similarity between a supervisor and subordinate on demographic characteristics, or maybe the congruence between the values of a person and those of their organization. Some of you might be aware that I've done some work in this area in the past on alternatives to difference scores, where the alternative is based on polynomial regression along with response surface methodology. And the surfaces that come out of that kind of work tend to look like something like this. Here we have a surface that has a downward curvature, and it's shaped like a parabola in the sense that it's curved, it's symmetric, it has no abrupt changes in slope. These kinds of surfaces can be used to study many questions of congruence, but spline regression is another possibility for how we could study congruence effects that offer some potential advantages over polynomial regression in certain situations. So instead of the curved surface that you saw for the polynomial regression, a spline surface would look something like this. So rather than a curved surface, you have something that resembles a tent. This tent can take on any kind of angle. It can take on different shapes or slopes on either side of this line, which we could call a seam. This could be the line of congruence between two constructs. So an advantage of spline regression is that we can estimate abrupt changes in slope, such as these. We can have asymmetry, and the surface can have any orientation. We also don't have to force curvature on either side of the congruence line. In some cases, researchers might want to hypothesize simply that on one side of the congruence line of fit, if you will, that a relationship, an outcome goes down. On the other side, maybe it remains flat. Those kinds of relationships can't be readily depicted with a polynomial regression equation because it forces a symmetric curve in the relationship. So with spline regression, you're able to model asymmetries, also zones of indifference along the congruence line. There may be a band on either side where a little bit too much or a little bit too little of, say, some reward really doesn't trigger a reaction. It isn't until you get out to the extremes. Spline regression involves nonlinear estimation, and I'm not referring to nonlinear estimation in terms of curves, but rather nonlinear combinations of parameters that are required to be estimated in order to be able to determine not only what the slope of the surface is on either side of that seam, but also the location of the seam itself. We can treat it as a hypothesis to be tested. So in my webcast, I'll provide an overview of spline regression. I'll provide some examples that in terms of the basic surfaces you might see in spline regression models, both in 2 dimensions and then moving to 3 dimensions. And then I'll take you through some empirical examples where we'll be looking at data that has to do with what people want and what they receive with regard to travel opportunities and job security in their jobs. And I'll take you through how we will estimate those surfaces with 0 seams, 1 seam, and 2 seams. These are nested models we can compare, and how to interpret the surfaces and test pretty much anything you'd like to be able to test from those surfaces. So I hope to see you on Friday, January 24th, and I'll see you then.